Good morning, everyone. Today is Tuesday, August 6th, and let's see what we need to do today. So here's our course outline, here's our calendar. Click on that calendar, go to today's date, Tuesday, August 6th. You're on Unit 1, and we're doing lessons 8 and 9, which are on radicals and equivalent expressions. What is due today? Today we have quiz 4 that is due, and we have a review quiz that is not for marks. It is for practice for the quote unquote test or assignments, according to Brightspace, that will be due tomorrow. Now, you only have till midnight tomorrow to complete that assignment, so make sure you spend your time wisely. And yeah, but we'll talk about that tomorrow. All right, so today let's get on with radicals and equivalent expressions. So, the very first thing that I will mention is that the notes for radicals are going to be in Unit 1, Lesson 4, for my quote unquote notes that I've posted. So Unit 1 Lesson 4, that's where you will find the notes that I'm using. Otherwise, you can follow the notes that are following the course outline and calendar over here, Unit 1, Lesson 8 and 9. So if you want to use, the different notes or you want to use my notes, both are acceptable. So let's get started. So lesson 4, working with radicals. What are radicals? Radicals are essentially the square root signs. But they can be more than just square roots. What do I mean by that? So you know how you have an exponent? An exponent can be, 5 to the power of 2, 5 squared. It's 5 times 5. You can have 5 to the power of 3, so that's 5 times 5 times 5. You can have 5 to the power of 4, or 10, or 12, or 100. It doesn't really matter. You can have, exponents can be any different numbers. So just like that, roots don't have to be just square roots. They can be cube roots or fourth roots or fifth roots. And they're essentially the opposite of exponents. So just like how multiplying and dividing are, opposites of one another, and they will cancel each other out. Just like roots are to exponents. And we're going to learn how to simplify roots and how to, add roots and multiply roots and kind of write it in exact notation. So you could, for this unit or this lesson, use a calculator and figure out a value, an approximate value, but a calculator will only give you a decimal value that's approximate. It won't give you an exact, notation. And we want you guys to learn how to write answers in the exact notation. So to give you an example of that, that's something that you should be familiar with is 2 over 3. So 2 over 3 is exact, whereas 0.66666 is an approximate. And you cannot write a fraction that's repeating as a decimal that's exact because it's always going to be approximation. It's always going to be rounded off to a certain decimal point, whereas 2 over 3 is the exact value. So just like that, square roots or roots, we will be writing in exact notation. And let's take a look at the initial part. So here we have some definitions. So radicand is a number or expression under the radical sign. So the number underneath the radical sign, so in this example here, the radicand would be the 4. Square root 4, the number underneath the radical sign. Entire radical is the whole radical, is the whole symbol with the square root, 45. And mixed radical is an example of a radical with a whole number in front, kind of like a mixed fraction. So here we have some more notes. Some numbers cannot be expressed as fractions. These are called irrational numbers. One type of irrational number is of the form square root n, where n is not a perfect square. These numbers are sometimes called radicals. An approximate value can be found for these irrational numbers using a calculator, but it is better to work with an exact value. Answer should be left in radical form when an exact answer is needed. Sometimes entire radicals can be simplified by removing perfect square factors. The resulting expression is called a mixed radical. And now we have some numbers that I recommend you either memorize or just know. And these are just perfect squares. Very simply, you just take the basic number line whole numbers, and then you square them. So 1 squared, 1. 2 squared, 4. 3 squared, 9. So all these squared numbers are perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on are all perfect squares. And these are going to come be important very soon, as you can see with these examples next. So let's do some examples here, and let's teach you how to simplify some radicals. Okay. So our first radical is square root 50. Square root 50, how can we simplify that? Well, the rule to simplify radicals is to see if there are any perfect square factors. Can 50 be divided by any of these perfect squares? So remember, the perfect squares were 1, 4, 9, 16. That's 4, 5, so 25. 6 is 36, 7 is 49, and so on. So can 50 be divided by any of these values? Well, 1 is always a factor, but 1 doesn't really do anything for us. It doesn't simplify anything. What about 50 divided by 4? 50 divided by 4, what do I get? Do I get a decimal value or do I get an answer? And you'll see that you'll get a decimal value. 50 divided by 9, once again, doesn't really work. You get a decimal, and we keep doing that. And we'll get a decimal, and we'll keep doing that until we get a whole number. And 50 divided by 25 is indeed a factor. 25 is a factor of 50, and when you do 50 divided by 25, you get 2. So I can split this term, 50, into its two factors. I can rewrite this as 50, sorry, not 50, I apologize, as 25 times 2. Okay, so everyone hopefully agrees that 25 times 2 is 50. So I didn't change the value. I didn't change anything. I just rewrote it in a different, format. Well, not format, just a different way. All right, so 25 times 2. Now I can split this into its individual radical. So square root 25 times square root 2 can also be written like this. And the reason why I write it like this is because I can simplify half of this, equation. And the square root 25, well, if you don't know, you can use the calculator. Square root 25 is a perfect square, meaning square root 25 is going to be the whole number 5. And this whole thing becomes 5 root 2, and that is the final answer. That is as simplified as possible. And that is what it means to simplify radicals. So we want the number inside the root to be as small as possible. In this example, we have root 27. Once again, let's see, we have our square roots, which are 1. 1 doesn't do much. 4. What is that next? 9, 16, 25. Okay, so 27 divided by 1 obviously just gives you 27, doesn't change anything. 27 divided by 4, that's not a, whole number, like it won't give you a factor. 27 divided by 9, what about 27 divided by 9? If you check that, you get 3. So that means 9 is a factor of 27. So we split this up into 9 times 3. And then we split them into 2 separate radicals. And we realize that, hey, square root 9 is just 3. And the root 3 cannot be simplified any further. So this is our final answer, 3 root 3. A lot of students make a mistake and I've seen this many times, whenever they take the square root of the 9, for some reason, they write 3 root 9 root 3 or something silly like that. They don't realize the root 9 just becomes 3. They still have, oh, sorry, I know what to do. This is what they do. They write root 3 root 3. They don't get rid of the square root sign. They don't realize that, oh, the 9 became a 3, but they're like, oh, we still got to keep that square root sign for some reason. Please don't be one of those students. Please don't make that mistake. Okay. And finally, we have C, 180.